Good evening to all of you. This is Dr. P. Ravindra Kumar. Today I am going to discuss the psychrometry. What is the significance of psychrometry, especially in mechanical engineering? So this particular content we are going to discuss. So first of all, observe the syllabus here, the psychrometric properties, the dry bulb temperature, wet bulb temperature, dew point temperature, thermodynamic wet bulb temperature, specific humidity, relative humidity, saturated air, vapor pressure, degree of saturation, adiabatic saturation, Carrier's equation, and psychrometric chart. So, what is meant by a psychrometric? The properties of a moist air are called the psychrometric properties. The properties of a moist air are called psychrometric properties. And the subject which deals with the behavior of a moist air is called as the psychrometric or psychrometry. So the science which deals with the study of a behavior of a moist air means it is a mixture of dry air and water vapor. So that is known as the psychrometry. Then what is the difference between the refrigeration and the air conditioning? Because this particular content is more useful in the refrigeration and the air conditioning application. So the refrigeration is nothing but process of providing and maintaining the temperature in the space below the atmospheric temperature. Whereas conditioning means the process of supplying the sufficient volume of clean air containing the specific amount of water vapor and maintaining the predetermined atmospheric condition within a selected enclosure. So for that purpose, we need to study the psychrometric in this particular unit. So then what is meant by dry bulb temperature? So the temperature which is measured by an ordinary thermometer is called as a dry bulb temperature and it is denoted by TD. The another technical variable, that is the wet bulb temperature. So the wet bulb temperature, it is the temperature measured by a thermometer, but its bulb here. So when its bulb is covered with wet cloth and exposed to the current rapidly moving air, so it is denoted by TW. So that means here whatever the temperature measured by this wet cloth surrounded to the bulb, then it is going to record the wet bulb temperature. Then dew point temperature, the temperature at which the water vapor present in air begins to condense when air is cooled. This is known as the dew point temperature. This is known as the dew point temperature. So in the same way, these are the various diagrammatic sketches which you can observe here. So this particular instrument is going to measure the wet bulb temperature and dry bulb temperature simultaneously. And this is the psychrometric chart. And this psychrometric chart represents this is the dew point temperature, this is the dry bulb temperature, and this is the wet bulb temperature. This is the wet bulb temperature. So on to the saturation line. So this is nothing but the saturation line. So on to the saturation line, the representation of the dew point temperature line, wet bulb temperature line, and the dry bulb temperature line. So this is how the things are presented. And when you observe the psychrometric chart, so students have to use a separate psychrometric properties for making the calculations of the properties of the atmospheric air. So the properties of atmospheric air means sometimes we need to measure the dry bulb temperature, wet bulb temperature, relative humidity, degree of saturation, and all these things. So this is the saturation. This is the psychrometric chart, and in this case, the constant volume lines representation. This is the enthalpy line representation, wet bulb temperature representation. So these are the different relative humidity lines. These are the different relative humidity lines. And this is the saturated line, and the specific humidity onto the y-axis, the dry bulb temperature onto the x-axis. So this is how the various relative humidity lines which are presented onto this particular site. Next, what is meant by relative humidity? It is defined as the ratio of the mass of the water vapor in a certain volume, in a certain volume of moist air at a given temperature to the mass of the water vapor in the same volume of saturated air but at the same temperature. So this is water at the same temperature. So mass of the water vapor to the mass of the water vapor at the saturated state condition at the same temperature. This is known as the relative humidity. So the specific humidity, you can also define the specific humidity is nothing but the mass of the water vapor to the mass of the dry air in a given volume of the mixer. So this is how the difference between this one and this one. Specific humidity and relative humidity. Then what is the difference between the absolute humidity and the relative humidity? So the absolute humidity is defined as the ratio of the mass of the water vapor in a certain volume of the moist air at a given temperature to the mass of the water vapor at atmospheric state condition. Whereas the relative humidity is nothing but ratio of the mass of the wet water vapor in a certain volume of the moist air at a given temperature to the mass of the water vapor in the same volume of the saturated air at the same temperature. So observe the relative humidity difference and the absolute humidity difference in this particular site. Then generally the relative humidity as compared to the specific humidity plays a vital role in such a way that for comfort air conditioning plays a vital role for comfort air conditioning and industrial air conditioning. So that is very important. The relative humidity is very important for comfort air conditioning and industrial air conditioning. So the relative humidity signifies the absorption capacity of the air. So if the initial relative humidity of air is less, it will absorb more moisture. It will absorb more moisture. So this is how the relative humidity. Then what is meant by degree of saturation? So the degree of saturation is defined as the ratio of a specific humidity of moist air to the specific humidity of saturated air at that temperature. See, observe this particular side. Specific humidity of moist air to the specific humidity of saturated air. So this is how the things are there. Now, the for the air conditioning side, the different process, the various psychrometric process which are mentioned over here. So that is the sensible heating process, sensible cooling process. All these processes are required for comfort air conditioning applications, especially for air conditioning applications. Humidification process, dehumidification, heating and humidification, cooling and dehumidification, adiabatic mixing, evaporative cooling process. So all these processes which are represented onto the psychrometric chart. So this is nothing but the humidification, adding the relative humidity or adding humidity to the existing air. Dehumidification, removing the humidity from the existed air. So this is nothing but the process of heating, sensible heating. This is nothing but the sensible cooling process. And this is nothing but the heating and humidification process. This is nothing but the cooling and dehumidification process. So all these processes are very much essential for the making the calculations of air conditioning, especially for the summer air conditioning and winter air conditioning side. Then what is meant by thermodynamic wet bulb temperature? So that is also the relative significance in refrigeration. So the thermodynamic refrigeration or the thermodynamic wet bulb temperature is nothing but the a temperature, that is it is the temperature a volume of air would have if cooled adiabatically to the saturation by evaporation of water into it, or latent heat being supplied by the volume of the air. So this you can also call it as a isobaric wet bulb temperature. You can also call it as a isobaric wet bulb temperature. So the thermodynamic wet bulb temperature is a thermodynamic property of a mixture of air and water vapor. The value indicated by a simple wet bulb thermometer often provides adequate approximation of the thermodynamic wet bulb temperature. So this is nothing but the thermodynamic wet bulb temperature and its expression. So there is one chart that is the Carrier's equation is there. So this Carrier's equation. So the modern tables of atmospheric air properties, these are based on correct versions. So for calculating the partial pressure of the water vapor, for calculating the partial pressure of the water vapor in the air, Many equations have been proposed, but out of which Dr. Carrier's equation is most widely used. So the Carrier's equation is mostly used for finding the partial pressure of the water vapor in air. So that is the significance. So this is the equation which is shown over here. So and its nomenclature is also presented over here. So that is about the psychrometric chart, and this is nothing but the adiabatic saturation. So here in the adiabatic saturation, what they have to do is the unsaturated air is passing in a chamber, and finally it is going to come out as the saturated air in an enclosed container. And here some of the water is to be placed over here, and this water is going to be evaporated. So this is the adiabatic saturation process. This is the adiabatic saturation process. Initially it is in unsaturated state, and this is the saturated state. So this particular point is nothing but the dew point of unsaturated air, dew point of unsaturated air. So this is one insulated chamber. So this is nothing but insulated chamber. First, initially the unsaturated air is passing up, and this some of the water is going to be evaporated, and finally the water is going to be come out as the saturated air. So when this point is reached, the thermal equilibrium exists with respect to the water, air, and water vapor, and consequently the air gets saturated. So this equilibrium temperature is called as the adiabatic saturation temperature. Adiabatic saturation temperature. So there is a vapor pressure is also there. The vapor pressure is also known as a vapor equilibrium pressure, and this can be defined as the pressure exerted by a vapor, pressure exerted by a vapor with its condensed phases in a closed system at a given temperature. So this equilibrium pressure is known, it is known to serve as an indicator of the evaporation of the rate of the liquid. So this is nothing but the significance of the vapor pressure. And in the same way, the characteristics of the vapor pressure where a student has to learn. And now, in a psychrometric chart, a student has to identify there is one alignment circle is also there. So, one alignment circle is there. So, it's a reference point which is indicated at a certain dry bulb temperature, at certain dry bulb temperature, and at a certain relative humidity, and which is having the moisture content at this particular state. So this is the psychrometric chart. It is the representation of the dry bulb temperature onto the x-axis and the specific humidity onto the y-axis, and also moreover the pressure of the water vapor, the moisture content of the vapor. So this is nothing but the psychrometric chart representation. And in addition to this one, some of the conclusions or some of the directions which you can draw from the psychrometric chart. So the chart is constructed under this particular condition that the dry bulb temperature of a unit mass of a dry air for different humidity contents or humidity ratios are indicated by the vertical line. So how the vertical lines and how the vertical line, horizontal lines, how the inclined lines. So all these particular things which are presented in a psychrometric process. So these are the logical deductions which you can draw. That means the pressure of the water vapor in mm of mercury is shown in the scale at the left hand side, and it is nothing but the absolute pressure of the steam. So like that one, the dew point temperature and the constant relative humidity lines, enthalpy lines, wet bulb temperature lines, and all these lines are represented onto the psychrometric chart. So there are certain the things which we should have to know that if the dry bulb temperature and wet bulb temperatures are known, then the relative humidity can be easily read from the chart. If the dry bulb temperature and relative humidity are known, then wet bulb temperature can be found from the psychrometric chart. If the wet bulb temperature, relative humidity are known, then the dry bulb temperature can be easily found out from this particular things from the chart. So this is all about the various technical terms connected to the psychrometric chart. So this is the all about the psychrometric and its significance and its importance. Thank you, one and all.